ठीक है. So up to this point we have discussed leptons, mesons, baryons. ठीक है. In baryons two categories were there. That was nucleons and hyperons. Now there is one more category. They are baryons, but their mass is greater as compared to hyperons. So these are the baryons whose mass is greater than hyperons. Beta. So first is delta particles, delta quark, delta particles here. So first is delta particles. First category is delta particles. So four type of delta particles are there. Delta plus plus, delta plus, delta neutral, and delta negative. Delta negative. So four type of these delta particles are present. They are all baryons. So baryons. So I can write their baryon number is 1. For all the four, their baryon number is plus 1. Plus 1. If you look at their spin and parity J pi, spin is 3 by 2. So their spin is 3 by 2 plus. ठीक है. So spin of all these delta particle is 3 by 2 plus. Now, strangeness number, another number that is strangeness. So strangeness number is 0. Strangeness number is 0 for these particles. So baryon number is plus 1 because they are baryons. Strangeness, they are not strange particle. Strangeness number is 0. Spin and parity for all the four. Spin and parity, that is 3 by 2 plus. Now, next is multiplet. ठीक है. How many particles are here? ठीक है. They are four particle, four charge states. So multiplet M, that is equal to 2i plus 1, 2i plus 1, and this is equal to 4. So what will be I? I will be 3 by 2. So what is the I here? If you look at I number is 3 by 2 for this. ठीक है. Now, in strong interaction, all the four particles, they are going to behave as a single particle. Strong interaction, that is in strong interaction, all the four particles, they will behave in the same way. Strong interaction cannot recognize these particles. But when you will place, because they are carrying different charges, so when you are going to place these particles in electromagnetic interaction, this single particle state, it is going to split into four charge state. So to represent these four charge state, I am writing I3 or IZ. ठीक है. So what are the possible what are the values of I3 here? That will be plus 3 by 2, plus 1 by 2, minus 1 by 2, and minus 3 by 2. So this highest value of I3, it will be assigned with the particle having highest charge. Highest charge is carried by delta plus plus. So this is going to have plus 3 by 2. Delta plus, that will have plus 1 by 2. This delta naught, that will have minus 1 by 2. And delta minus, having lowest charge, will have lowest value of I3. So this is. So basically these delta particles are like this. So four delta particles which are actually heavy baryons. They are baryons. So they are like this. So they are heavy baryons, but are delta particles. So these are delta particles. Now second type of heavy baryons.
Hello,
They
sir.
are, yes, beta, please.
The last one is I3 or minus I3.
I3 is plus 3 by 2 plus 1 by 2 minus, is it anything wrong? Hello?
No, sir. The heading that I asked about I3.
I3. Okay. This is just I3, not minus here. Is it okay now?
Yes, sir. Okay.
It is I3 or you can also say it as IZ. Okay, you can also call it as IZ. Now, next is excited states of sigma particles. So there are sigma particles, so excited states of sigma particles will be there. Excited states of sigma. Okay. So next heavy type of baryons are excited state of sigma. So they will be sigma plus and star will be there. Star is having that they are representing the excited state. Then sigma naught and star will be there. And then sigma negative and that will be star. Now baryon number for these is 1 because they are baryons, so plus 1. If you look at this J pi, that is 3 by 2 plus this is J pi. If you look at this strangeness number, they are having strangeness number. Kitna hoga? What will be the value? That will be -1. Strangeness number is -1. Now, what will be the I number or multiplicity here? So if you look here, multiplicity is 3. So I can write here multiplicity M is 2i plus 1 equal to 3. So what will be I? I will be 1. I3 or IZ, it will have three possible values: +1, 0 and -1. -1. Okay. So I number is 1 here. Isospin is 1 and that is +1, 0 and -1. This will be, these are the values. So what is this? This is B if you want to write. This is J pi. This is strangeness number. I number is here and this is I3. This is I3. So these are the excited states of sigma. Similarly, you are having excited states of cascade particles. Next is excited states of cascade. Excited,
Yes, sir.
just a bit. Can I go to next now?
Yes, sir.
Next is excited states of cascades. So one is sigma neutral and in the excited state, and this is sigma negative and this is excited state. Okay. So first is baryon number. For this baryon number is +1, +1. If you look at J pi is 3 by 2 plus 3 by 2 plus. Okay. Strangeness number if you write, that is -2, -2. Okay. After that, if you write I, so here basically these are two particle, multiplicity will be 2. So I number will be 1 by 2, 1 by 2, 1 by 2, 1 by 2. And this I3, this will be +1 by 2 here and that will be -1 by 2. And last is, okay, last is this omega minus. Okay, this is omega minus itself. So actually it is in the both categories. Okay, this was a transition particle. We have also written this there in hyperons. ठीक है, but because it is also having a spin 3 by 2 plus, so I'm also writing here. So this will be plus 1 because this is a baryon here. Strangeness number is minus 3 here, and this will be I will be 0 and this will be 0. ठीक है. So this is the last particle, last heavy baryons. So these are heavy baryons, beta. So now I have mentioned you most of the particles with which we are going to deal in questions, numericals. Please note it down quickly.
Sir, can I have previous slide 1 second?
Okay, beta. This was the first one.
Okay, sir.
Okay. This is second one. And next is hypercharge.
The
Next
previous
is
slide one.
okay.
Okay, sir.
There is one more number that is called as hypercharge. Hypercharge. Hypercharge is represented by capital Y. So this is Y, and it will be equal to baryon number plus strangeness number, B plus S. So B plus S, together it is known as hypercharge. Now, if you look at B, B is always conserved. So B is, B remains conserved, conserved in weak, strong, and electromagnetic EM interaction. In all the three interaction, this will be conserved. ठीक है. But if you look at this as, ठीक है, if you look at this as, it will be conserved, remains conserved, in strong and electromagnetic interaction. Strong and EM, electromagnetic interaction. ठीक है. B. However, it may not be conserved. So may or may not, it may or may not be conserved. May not be conserved in weak interaction. In weak interactions. Okay. So this is the situation. So this is the situation corresponding to conservation of B and S. Now B plus S is represented by hypercharge. So basically hypercharge, what will happen? Because it will always be conserved. So only this is going to decide the conservation of Y in weak, strong, and electromagnetic interaction. So that will be corresponding to S. So hypercharge try to understand this. B will always be conserved, and in strong and electromagnetic, S will also be conserved. So hypercharge will remain conserved. Will remain conserved. Will remain conserved in in strong and electromagnetic. In electromagnetic interaction. And B may or may not be conserved. Not be conserved. Sorry. So this is hypercharge. Okay, this is another number that is known as hypercharge. So hypercharge will be conserved in strong and electromagnetic, but in weak, it may or may not be conserved. It may or may not be conserved. Next is Gellmann-Nishijima formula. Next is,
Sir,
yes, beta. Okay, beta, just
Sir,
one second.
previous.
Yes, beta, 1 second. Gellmann and Nishijima formula. Next is Gellmann and Nishijima formula.
Sir, second point is may or may not be considered in weak interaction.
In weak interaction, beta. So this is delta
Hypercharge.
S here. Either it will remain conserved, then it will be 0 delta S. And if it is changing, then it will be plus minus 1. Okay? In conserved in weak interaction, beta here. In weak interaction. Next is Gellmann and Nishijima formula. So basically Gellmann connected a charge on a particle with I3. Can I go to the next?
Sir.
So basically what this formula is saying, for particles here, so there are two formulas for particles. So this formula says that charge on a particle Q, that will be equal to I3 plus B plus S by 2. Okay, you can take any of the particle. This formula is going to be satisfied. For example, I'm taking this pi minus. Okay, so pi minus, look, what is I3 for pi minus? I3 कितना होता है? That is -1. B is 0 here and S is 0. S is 0. So what will be the charge? Q will be equal to I3, that is -1 plus B plus S 0 plus 0 by 2. So how much charge this particle is going to have? That is -1. So minus E charge. So how many unit of charge is there? So -1 E charge will be there. So in this way, you can apply this formula to find out the charge on any of the particles. So charge on a particle is connected with I3, B and S. B plus S, this is also known as hypercharge. So you can also write it as I3 plus Y by 2, and this will be the charge. This is the first formula, and this is for the particles. For mesons, for baryons, okay? This formula is applicable. Now B for quarks. For quarks. Okay, for quarks, this formula was modified, and now formula is this: Q is equal to I3 plus 1 by 2. Here it is not only B plus S plus top plus beauty. Okay, this formula will be a little bit modified. ठीक है ना? This will be a little bit modified. कौन कौन सा होगा? एक और भी तो होगा, charm भी होगा बेटा. Please modify. This is baryon number, then charm number, or you can write B plus S. This was already there. Plus charm is there. Top and beauty. Now it's correct. This is B star. So this is. So these four numbers, they are corresponding to quarks. And this is baryon number. This is baryon number. So this is the charge on a quark. Any of the quark you can choose. any of the quark. For example, suppose you choose a charm. Okay, if I choose charm quark, how much charge it is going to have? Q plus 2 by 3e. 2 by 3e. So what is for charm quark? What is I3? That will be 0 plus this will be 1 by 2. Baryon number is 1 by 3. Strangeness number is 0. 0 here. What is for charm number? This will be 1. 1 plus top number is 0 plus this is 0. So this will be 4 by 3. So this will be 1 by 2 into 4 by 3. So this will be equal to 2 by 3 beta. So this will be the charge on it. ठीक है ना? This is going to be the charge on it. If you took strange quark, then you know that on the strange quark Q is minus 1 by 3e. So write these numbers for strange quark here. This was for charm quark. For charm. Here I'm writing for strange quark. What will be Q for strange quark? I3 0 plus 1 by 2. This will be 1 by 3. That is okay. For strange quark, S number is minus 1 strangeness. Rest of charm, top, beauty, they will be 0. So how much it will be? This will be 1 minus 3. So minus 2 by 3. So this will be minus 1 by 3 here. So this is the charge on the strange quark. So in this way, you can find out. In this way, you can find out the charge on any of the particles if you know these numbers. So you basically Gellmann and Nishijima formula, they have connected the charge carried by a particle with various numbers. Baryon number, strangeness number. For quarks, they included 3 more numbers, C, T, and B star. So this is known as Gellmann-Nishijima formula. Please note it down. Can I go to next?
Sir,
Yes, but next is eightfold way. Next is eightfold way. ठीक है. The objective of this is, लिखिए please write, the objective of eightfold way is to classify. The objective of the eightfold way is to classify. Is to classify hadrons. To classify hadrons in terms of multiplets, in terms of multiplets by considering same spin, by considering same spin, but different strangeness, but different strangeness. But different strangeness. So basically, what is this? This is a method to classify hadrons. There are various methods by which you are going to classify the particle. So basically, this eightfold way was a method by which hadrons were classified. And how they were classified? They were clubbing particles having same spin, but different strangeness number. Okay, but different strangeness number. So in such a way they were classifying these hadrons. So three type of octet, two octet structure they find out first. Okay, so first classification was spin zero. कैसा first was, I can write here spin zero. तो spin कितना था बेटा? ठीक है, so first type of category they were choosing, that was spin zero, odd parity. स्पिन जीरो स्पिन होना चाहिए, ओड पैरिटी होना चाहिए, ओड पैरिटी, मीजोन्स, मीजोन्स, octet. Octet. Why they are saying it octet? I will come to this. So first category was of the particle whose spin is zero. They have odd parity. They are mesons and they are forming an octet. So this was the first category. First category is spin zero, odd parity, mesons, octet. So for this purpose, here on the y-axis, they are having y number, hypercharge number, and here they are having I3. Here they are having I3. Okay? So basically they are going to place each and every mesons of this category on this chart here. So on the y-axis you have hypercharge, and here you are going to have I3 number. So this will be, I write here 0. Why I am taking 0? +1 here, and I write -1 here. You will come to know this. And here it will be from -1, then I3 it may be -half. It is okay. It will be 0. It will be here +half, and that will be +1. These are, ठीक है ना? So they have plotted y as a function of I3. Now look at mesons one by one. So if you look at mesons, one is pi plus, pi naught, and pi minus. ठीक है? What is there? Y is b plus s. So what is b and what is s? S is 0 for them. Baryon number, that is 0. So what is y number for these three? Y number is 0 for all three of them. And what is I3? I3. I3 will be +1. It will be 0 and this will be -1. So now look at where will be this pi plus particle. I3 should be +1 here. And what is y? Y is 0. So where will be my pi particle? My pi particle will be here pi plus. Pi plus. So for pi plus, you can look here. I3 is 0. I3 is +1 and y is 0. So y is 0 here and this is. Now next is pi naught. So pi naught will be here. This will be pi naught. For pi naught, this is 0, 0. And for the next pi minus, this is -1 and 0. So -1 is here, and this will be pi minus. This will be pi minus. So here you are going to have three particles. So three mesons we have placed here on this chart. Second is K plus. So if you look at K plus, so this is K plus and K naught. Two are here. If you look at, they are not baryons, they are strange, but strangeness number they are going to have. They are not baryons, so B will be 0. What will be their strangeness? Strangeness is +1, +1. So what will be Y number for them? Y number will be +1, +1. So for them, Y number is +1. And I3, it is carrying higher charge, so it will have +half. and it will have minus half. So where will be this K naught? I3 will be minus half and plus 1. Minus half is here and plus 1 is here. So this will be K naught here. K naught. So first I have placed it K naught. Now look at this K plus. This is plus half and plus 1. Plus half is here. And this is K. And this is K plus. This particle is here. Last is eta. For eta, B number is 0. Strangeness number. What is the strangeness number for that? That is 0. ठीक है, strangeness number is 0. So Y number is 0 if you look at eta naught. Y number is 0 for it. And I number is also 0. So it will be 0. This will be 0 and 0. So here, this will be eta naught. Two particles will be at this position. ठीक है? Now, next. Antiparticles. If you take the antiparticles of this, so this will be, look here, this will be antiparticle, this will be K naught bar, and next is K bar negative. So if you look at their baryon number is 0 for them. Their strangeness number, that is minus 1. So Y number will be minus 1. And if you look at their I3 number, this will have plus half and this will have minus half. ठीक है, minus. So first this y is minus 1. Y is minus 1 is here. And this is this one k minus. So it will be k bar minus here. K bar minus. If you look at this k naught bar, ठीक है, this will be plus and here this will be minus 1. So this will be k bar naught. And if you connect this, so it is going to form a structure that is called as octet. A type of structure is this, and this is called as octet. Because it is forming this type of octet, that's why you are saying it as octet. Okay? So this is the first one. This type of octet is formed by spin 0 mesons having odd parity octet. So this is the first octet. Is it clear to everyone? Hello?
Yes, sir.
Okay, beta. Next is second is even parity. Please note it down quickly so that I can go to the next. Number 2 is even parity. Spin half. ठीक है. So spin is half. ठीक है. So if you look at even parity and spin half, even parity and spin half, so what type of particle they may be? They may be baryons. So what type of particle you need whose parity is even, spin is half, so they are baryon. And they are also going to form the octet. Baryon octet. This is again draw a vertical line. Here we are having hypercharge. This will be 0 here. This will be plus 1 and this will be minus 1. And here we can have I3, it is here, you can say minus 1, minus half. This will be 0, plus half, and plus 1, and plus 1. This will be, ठीक है? So one by one, first is proton and neutron. Proton and neutron. What will be Y number? Y number is B plus S. S is 0 for them. B is 1. So Y number is 1 and 1. And if you look at I3, I3 is plus half. And this will be for minus half. So where will be neutron? Neutron will be at Y equal to 1 and minus half. Minus half is here and 1 is here. ठीक है ना? So, okay. This is B plus, what I have written here, B plus S. Okay. Minus half and this will be, here it will be neutron. ठीक है ना? It will be neutron here. So first I place this. So first I place this neutron. Second, 1 and half. So half is here and 1 is here. So this will be proton here. So first is this. Okay. Then second is sigma. If you look at sigma, sigma minus, sigma not, sigma plus. Okay. What is the baryon number? They are having baryon number plus 1. What is strangeness number? Strangeness number is minus 1. So B plus S will be 0. So Y number is 0 for all the three. But if you look at I3, that will be minus 1, 0 and plus 1. So with minus 1, it will be 0. So minus 1 and 0 here, this will be sigma minus. ठीक है? This 0 and 0, 0 and 0 here, it will be sigma plus, sigma naught. Sigma naught. Plus 1 and 0, plus 1 and 0 here, this will be sigma plus. So these three I have placed here. Next is cascade. So cascade neutral or negative first I write, then cascade neutral. Neutral. What is the B number? B number is plus 1, but strangeness is minus 2. So Y number will be minus 1 here. Minus 1, minus 1. And if you look at I3, this is having minus half. This is having plus half. So at minus half, minus 1, minus half, minus 1, this will be cascade negative here. And here plus 1, plus half, minus 1, plus half, minus 1. That will be cascade neutral. And last is omega. Omega minus, B number is 1. Strangeness number is minus 3. It's 3. So what will be iska? Yeah, I think कोई नहीं, ये this will not be a part of this. Why? Why it will not be a part of this? I've written it wrongly because if you look at its spin is 3 by 2. So this will not be a part of this octet. So I have wrongly written it. So one more particle will be there. Okay, that is lambda naught, first particle. Sorry, I forget this, lambda naught. What is lambda naught? What will be Y? B number is 1, S number is 0. So this will be 1 and I will be 0. So I3 0 and Y1 0, 0 and Y number. This will, Y should be G, Y will be B plus S. B is 1 and strangeness is 1. So it will be 0. So it will be 0 and 0. It's okay now. Now it is lambda naught. So this type of octet will be there. So this is another octet. So actually at the center in both octet, 2 particles are there. So that's why I remember there were 2 particles. One was missing. Okay, so this will be 0 here. Is this clear to everyone?
Yes, sir.
Now, last one, but a third one. Okay, that is called as even parity. Spin 3 by 2 baryon decouplet. So next is baryon decouplet. Please note it down. Last is baryon decouplet. This is third category. So they're classifying hadrons. So 2 octets were formed and 1 decouplet. Okay, and 1 decouplet is formed here. Even parity. Just one second. Even parity. Spin 3/2. Spin 3/2. Baryon decouplet. Baryon decouplet. This is the third category they created out of this hadrons. This is third category. Now, here, what type of spin is? Spin is 3/2. So heavy baryons. Here in this category, which particles will be there? They will be heavy baryons having spin 3/2. So this will be Y number here. So I'm writing here +2. And this will be +1. This will be 0, -1, -2.
What is written here after baryon? Decouplet?
Decouplet. Correct.
Okay, sir.
Decouplet. And then here you are having I3. -3/2. Then that is -1. -1/2. 0. +1/2. 3/2. Okay. So first category is these delta particles. So I'm writing in reverse order. Delta minus, delta naught. And this will be just delta plus, delta plus plus. So you have to write B plus S. B is 1, S is 0. Okay, B is, so what will be Y? So here baryon number is +1, strangeness number is 0. So Y number will be 1, 1, 1 plus 1. This will be. And if you look write I3, this will be -3/2, -1/2, +1/2, +3/2. So -3/2 and +1. So this is -3/2 and +1. So here this will be delta minus. Delta minus. ठीक है. Next is at -1/2, at -1/2 here this will be delta naught. This will be +½ This will be delta minus. And this will be 3/2. This will be delta plus plus. Delta plus, delta plus. This will be. Okay. Next. Then there are sigma. Sigma. And this will be sigma negative star. Sigma neutral star. Sigma positive star. And here what will be this Y number? Strangeness number here is -1. Baryon number is +1. So this will be 0, 0, 0. And here I3 number. I3 number will be -1, 0 and +1. So -1 and 0. So this is -1 and 0 here. This will be sigma minus star. This will be 0, 0. So 0 and 0. This will be sigma neutral star. And this will be plus 1 and 0. This will be sigma plus and star. It will be like this. Okay, this will be sigma. After sigma, there will be cascade stars. So this will be cascade negative star. And this will be cascade neutral star. Okay, so that is baryon number is +1, strangeness number is -2. So this y number will be -1 here and -1 here. And this is I3. I3 is -half. And this will be +half. Okay, this will be -half and +half. So -half -1. So -half -1 will be here. So this will be cascade negative. Cascade negative. And here this is +1 and this will be cascade neutral. Okay. And last, if you look at this will be omega minus. Okay, what will be omega minus? Omega minus, what will be y number? Baryon number is 1, strangeness number is -3, so -2. Y will be -2 and I3 will be 0. So this type of structure will be formed. This is called as decouplet. Okay, this type of decouplet will be formed. So this structure, they call it as decouplet. So this type of decouplet is formed. So these three eightfold way is nothing special. Basically, it is very simple. It is a way of classification of hadrons. So by clubbing the multiplets having same spin but different strangeness number, they have here. ठीक है ना? They have grouped them into three categories. ठीक है? Spin 0, if you look at spin half, and spin 3/2 hadrons. So here. So this is a way to classify them. Is it okay up to this point, beta?
Sir, please 2 slides back. I have a question.
Okay. This one?
Sir, one more.
Okay, beta.
सर हमने इसमें के पार्टिकल का एंटी पार्टिकल लिया है
Yes.
लेकिन पाई का नहीं लिया हम या ना ईटा का लिया हमने
Actually, they were not required here. If you take pi, देखो, anti-particle of pi naught is pi naught itself. If you take anti-particles of this, so this will be pi bar and this will be positive. This will be pi, ठीक है? This will be bar, ठीक है? And this will be negative here, ठीक है? So these two are there. And is this okay or
Yes, sir.
something else? No, this is not okay. ठीक है ना? This is not okay. Why? Can you tell me? Because you are saying that here. So what is the reason? Try to understand. If you look at the mesons, then two pi mesons are there. One is pi plus and pi naught. Antiparticle of pi plus is pi minus, and antiparticle of this is pi naught.
Pi naught.
So you have considered all the pions here.
Okay, sir.
ठीक है?
Okay.
So this was the case. Now come to the next. Next is conservation laws. Please note it down. Then I will go to conservation laws. This was there.
Sir, please go
Yes,
again with this omega, how it comes.
this omega
Yes.
or omega minus. ठीक है? What is the baryon number? Baryon number is +1. What is the strangeness number? That is -3. So y number that will be b plus s, that will be minus 2. ठीक है? This is not forming a multiplet, so it's I3 or I number that will be 0. ठीक है? So this is 0 here, I3, and y number is minus 2, so I have placed here. ठीक है? So I have placed it here.
Okay, thank you.
Welcome, beta. Next. Next is conservation laws. Conservation laws. Please write, there are two type of conservation laws. There are two type of conservation laws. Number one, exact laws. Exact laws. लिखिए, please write here in exact laws. These conservation laws are followed in every reaction or interaction. These conservation laws are followed in every reaction or interaction. Full stop. If
Sir, in
every reaction or interaction, in every reaction or interaction, full stop. If any of these exact laws, please write like this. If any of these conservation law is not followed, if any of these conservation laws is not followed, then that interaction, if any of these conservation laws is not followed, then that interaction will not be possible. Then that interaction will not be possible. Then that interaction will not be possible here. So first is exact laws. Here three type of interactions are there. First is strong interaction. Second is electromagnetic interaction. And third is weak interaction. ठीक है? Because size of these fundamental particles that is so small that we are not considering here the gravitational interaction. I will come to that later on. ठीक है ना? Now next is quantities conserved. Here I am writing quantities which are conserved. So first is, I can write first. First is energy. ठीक है? So energy is conserved in every of the, so energy of the system here I'm talking energy of the system where you are also considering the conservation of mass, means conversion of mass into energy and energy into mass. So you are taking care of that. So energy is always conserved. So energy will be conserved here, here, and here. Yes, energy will be conserved. In strong interaction, electromagnetic interaction, and weak interaction, energy will be conserved. Okay? So first quantity that will be conserved will be energy. Second is linear momentum. Okay? If no external force is acting on the system, then linear momentum will be conserved. Linear momentum will be conserved. So it will be conserved if no external force is acting on the system. Number 3, angular momentum. If no external torque is acting on the system, then angular momentum will be conserved. This will be conserved. So they are all conserved. If any of these conservation law is not followed, then that type of interaction will not be possible. Next is charge. Charge would be conserved. So charge will be conserved. charge will be conserved. 5. Lepton numbers L, electron lepton number, mu lepton number, tau lepton number. All these lepton numbers separately they should be conserved. So they should be conserved separately. Here you can write all the four should be conserved separately. All the four should be conserved separately. And last is baryon number. Last is B, baryon number. Baryon number should also be conserved. So here there is no choice. A reaction will be possible and interaction will be possible only if all these conservation laws are followed. If any of one, if out of these six, a single one is not followed, then that interaction is not possible. Then that interaction is not possible here. So they are called as exact laws. What do you call them? You call them exact laws. You call them exact laws. Next. Second is approximate conservation laws. Next is approximate conservation laws. Next category is approximate conservation laws. Approximate conservation laws. Conservation laws. ठीक है? They are also known as selection rules. ठीक है? So they are also known as, you can write, they are also known as selection rules. ठीक है? Why? Because these rules help us to distinguish that a given interaction is weak, strong, or electromagnetic. You can find out with the help of these. ठीक है? You can find out that which type of interaction is there. So out of this, here I am writing quantities. First, quantities. Second is strong here, strong interaction. Then electromagnetic. And last, weak interaction. So first is I. Iso spin beta. First is I. ठीक है? First is I. Iso spin. Iso spin, remember this. This is very important. Here, yes. In case of strong interaction, this is conserved. But here, in this case, it is no. And in weak interaction, it will not be followed. So iso spin is not going to be followed in case of electromagnetic and weak. This will be. Next, if you look at I3, here I3 will be followed in strong, in EM, but it will not be followed here in weak interaction. In weak interaction. ठीक है? This is I3. Next is strangeness. Third is strangeness number. Strangeness number, it will be followed in here strong, electromagnetic, and here may or may not. ठीक है? Here I am writing may, or in general may or may not. May or may not. Plus minus 1. It will be. So this is the strangeness number. Next is parity. Parity. Next is charge conjugation. three other properties. I have not discussed these properties up to this point. And next is one more is there. Parity, charge conjugation, and third is time reversal. ठीक है, CPT, time reversal. I will explain these three also. So here, all the three, they will be satisfied here. In a strong interaction, you can look. All the conservation laws will be followed in a strong interaction. Throughout, there is yes. In electromagnetic, there is throughout yes. This is an exception here. Basically, I will not be conserved in electromagnetic. Remember this. This is yes, this is yes, this is yes. And weak. In weak, most of the time it is no. So you have to remember these conservation laws. ठीक है? So these are the conservation laws. So most of the aspects I have discussed here. Now two things are left. In the next class, first I will discuss these four interactions: gravitational interaction, strong interaction, weak interaction, electromagnetic interaction first. And then I will discuss what is parity, charge conjugate, ठीक है ना? And this time reversal. This is charge conjugation. So in next class, I will complete the theoretical part of this. After that, I will take 2 or 3 classes in which I will discuss numericals. Okay? So all possible type of numericals, whatever is possible in particle physics, I'm going to discuss. I will take 2, 3 classes. And after that, you can solve any of the question related to particle physics. So please note it down. And for today, I'm going to stop here. So I will need one more class for theory part. So I'm showing you all these slides. Please take a screenshot. This is the first one. First one. Second. Third. Fourth. Fifth. Sixth. Seven. Eight. 9. And 10. ठीक है बेटा. Okay बेटा. Thank you very much.